Okay, good morning, everyone, and welcome back to class. I hope everything's going as well as it can be for you. We're in the home stretch here. We got the last 2 weeks of class, and yeah, I hope you're feeling like you're making good progress. And if you need any support, please reach out. I've been doing what I can to help everybody out as they've been emailing me, and if you've been emailing me, I appreciate it. So let's get on with what today's work is about. Today we're going to be talking about nutrient cycling, and we're going to talk about what the essential nutrients for life are. Get a little definition of nutrients going, where they come from, where they go, the processes that move them, and then how people are impacting nutrient cycling, and then how is this modeled using a systems perspective. And your assignment will deal with that, reading and understanding diagrams of these nutrient cycles. So let me move forward, and we will talk a little bit about this. So I'm going to go backwards. There we go. All right. So first of all, the idea of nutrients is kind of complex, but we're going to start with just thinking about the elements that are within our body and that make up all living things, right? So most of what living things are is carbon, oxygen, and hydrogen, right? But then there's also nitrogen, calcium, phosphorus, and potassium are all essential elements for life. And, we get these things through what we eat, right? And so the idea of a nutrient is that it's really any element or molecule that is necessary for life. And it depends whose definition you read, but that's just the basic gist of it, is any element or molecule that's essential for life that we get from other sources, usually food and the things that we eat, right? And so for people, that means farms, and farming looks a lot of different ways. We've got some different models of farms here, from a backyard garden to a small organic farm is what we would normally think of as farm. A lot of people think of as farms, but then modern farming looks a lot different. We've got a big row upon row upon row of lettuce, that looks like, and then over in the corner is actually the RIT's indoor hydroponics farm that's back behind the SAU. And so all of these different things, though, rely on bringing nutrients into the system and having the plants incorporate those nutrients into their tissues, into their cells, so that then animals can consume them and continue living, right? And so we can kind of think about the nutrient cycles and the systems like this, right? We're going to use some language here that's similar to what we've been using, but there's a source, so there's a place that these nutrients start. There's some sort of process that moves it from that source, so either a biotic or abiotic process. And then there's a sink, and that's a place that it goes. And one of the things as we look at some diagrams later is to also think about quantities. So how big is the source, how much is available in a particular reservoir, and how much is where does it go, how big is that bucket that the sink is, right? And so I'm going to focus today on some essential nutrients for plant life. And if you do any gardening or plan to, it's a good idea to know the NPK ratio, right? So nitrogen, phosphorus, and potassium. And these are all, most fertilizers that you buy have these three things listed in their quantities, right? And so phosphorus is really important to plants. It's important for germination and the just overall resilience of the plant. But then also phosphorus is really important in all things, in ATP, ADP, NADP, NADPH, right? All these different carrier molecules. And then also in DNA, there's phosphorus in DNA. And so it's a really important nutrient for life. And so if we stop and think for a minute, we need phosphorus in our bodies. And so where did that food come from? Or I'm sorry, the food that we ate, where did that phosphorus in that food come from, right? How did it get there? And then once you got it, you ate it, where did it go? And then it won't always be in your body. So then where's it going to go after it leaves, right? And what processes are going to move this phosphorus along the chain and through the system. And I bet what we're going to talk about next is actually something you really haven't thought much about, right? So the phosphorus in your food is coming from here, most of it, a lot of it. It's coming from phosphorus mines. There are phosphorus mines in the Sahara. This is one of the largest phosphorus mines on Earth. And you can read an article here, but there's a finite amount of phosphorus that's used in that's available for us to use in these kind of concentrated areas, right? So in the United States, in Florida, there are a lot of phosphate mines, and these mines are the result of the buildup of phosphorus that was moved through the system through organic means over long periods of time, and now it's being mined and used to feed our food. So you are probably made up of some phosphorus from one of these mines, right? And so, the way that this works is that there's marine organism rich sediments, right? So the phosphorus is locked up in marine organisms. It's compacted into rock, so that's the process, the formation of the rock, right? So then it's tied up in this phosphate rock. It's mined is the process, and then through the mining, it's turned into fertilizer, and then the fertilizer is applied to fields. That's the process, and then the plants incorporate it, and that continues it, right? And so now if we think about where's the phosphorus going, right? So not all of it stays in our body, and I think this is a crazy statistic, right? Is that in urine alone, 1.68 million metric tons of phosphorus is available in the urine, right? So we excrete it in the form of urine and feces, and that goes through the sewer system and ends up in a sewage treatment plant somewhere. Here in Rochester, the Van Lair treatment plant is down in Irondequoit next to Durand Eastman Park. And eventually it's discharged into Lake Ontario. And so, that's this. I bring up the statistics because people are starting to try to think about what a circular economy of phosphorus would look like, right? And so just here's a little map of sources and sinks, right? So you excrete as the process, goes to the wastewater treatment plant, the wastewater is processed, and then the phosphorus moves into a body of water. And so this model incorporates some of the agricultural inputs and outputs. And so agriculture is a huge source and sink of phosphorus, where the farms incorporate, they fertilize with the phosphorus, plants take it up and synthesize it into molecules and cells, and then the cows, if we're talking about a dairy farm, they eat the plant, so they consume and digest the plant, and so then they're able to incorporate phosphorus into their cells, and then they excrete this phosphorus, which then ends up either being spread on a field or ends up in a giant lagoon, and then it might run off into a body of water. So you can see where all of this is going. There's lots of phosphorus being put into our bodies of water through our own activities, but then the activities of farms. And so here's just a little diagram that shows, a cow and his role. But then the map on the side is the Genesee River watershed. And so it's hard for me to point out exactly where RIT is in this, but it's in there. And every one of those brown dots is what's called a concentrated animal feed operation. And so that's somewhere where there are, I think, more than 100 cows. It's either 50 or 100 cows. I looked that up before I did this. But and so all of those places play a role in adding phosphorus to the watershed, and then eventually all of that runs into Lake Ontario, right? And so it's just something for us to think about, and it's not a judgment. I just want to add that we have to eat, and so and dairy is an important part of our diet. So what does that mean to be sustainably farm and manage the inputs of phosphorus, and what does it mean to manage that appropriately? And so just coming back to this, right? So we talked about a bunch of different things, but I want to keep this in your mind. There's the source, There's the process and there's the sink, right? Where does it come from? How does it move? Where does it go? And so here are a few diagrams. We're going to talk Tuesday. The lesson's going to be a lot about the global carbon cycle. But this is just kind of showing the movement of carbon from different sources and sinks. It doesn't have the processes labeled, but it does have quantities listed. So all of those numbers mean how much, right? So the fluxes being the movement and the reservoirs being the boxes, right? And when we compare the nitrogen and phosphorus cycles, and I've got diagrams coming up next, right? So nitrogen and phosphorus are both essential for life, both in DNA. Nitrogen is specifically important in amino acids for photosynthesis and respiration. Phosphorus also important in photosynthesis and respiration. An important thing to know for both is that agriculture has greatly altered the natural cycles of both nitrogen and phosphorus. And what's really important is to understand that there are biochemical processes that create the organic forms that are usable by organisms. Bacteria is essential for incorporating nitrogen into the food system and into the biotic systems, and for phosphorus, it's plants. Plants are essential for bringing phosphorus into the biosphere. So your task, I'm going to skip this slide for a minute, but we're going to go to just looking here. What you're going to need to do for the assignment coming up is you're going to look at some different models of the phosphorus and nitrogen system. And I'm just going to switch here to the task screen. All right. So what you're going to do for today's work and your assignment number 7 is you're going to take some time to look at different models of the phosphorus cycle and the nitrogen cycle and the carbon cycle, and you're just going to do some identification of the processes, the sources. So those are the boxes. The processes, those are the things along the arrows, and the sinks. Those are the boxes where the arrows lead to, right? So, for example, rocks, weathering, and then the phosphorus ends up, weathering's the process, and then the sink is dissolved in soil, water, lakes, and rivers. What you'll quickly notice is that the sinks then become sources, and especially if there's some sort of circular movement. And that's an important thing to realize, is that a lot of this moves circularly. But you might also find that there are some sinks where things end up and don't continue moving. Here's one. This is nitrogen cycle. Not all of the arrows are labeled, but you can figure that out. And then here's the carbon cycle diagram. This one is interesting because it has the valves, so it kind of gives that idea of that there can be changing rates of movement depending on different variables. But this is the carbon cycle. So I tried to make it straightforward. And then the other thing that I added in was that I want you to think about which processes are biotic, which processes involve living things, and then highlight those. So you'll have to identify something like weathering is not a biotic process, but excretion is a biotic process, right? So those are things to think about, and that's what you need to do for your assignment today. I just want to go here to this to-do list real quick. Of course, watch this video, study the slideshow. If you haven't read chapter 46 yet, make sure that you read that before Thursday's exam. So your next step is to complete assignment 7 before Sunday, but on Thursday we have an exam. Check my courses for the study guide for that. I also want to highlight the need to continue working on your bioexplorations. If you're having a challenge with that, let me know, but I put up on my courses under the discussions. There's some ideas and examples there. And then I've set one up that you can participate in, and I'm hoping you will. I'll send a survey out to see whether or not you plan to participate. But on Tuesday, April 21st, so that's next Tuesday from 12:30 to 1:45, we'll have a discussion about climate change and how it relates to careers. with some faculty from SUNY Environmental Science and Forestry. They're stationed in the Adirondacks right now at a field station there. And so I think that'll be an interesting discussion. So join us for that. And then Thursday also, from 12:30 to 1:45. It's optional, but I've got an online simulation game, fish banks, that we'll be working on. I'll share the link if you want to practice a little bit before Thursday, but I'll send out some more information on that. But the big thing is the exam coming up on Thursday. Read the study guide for what the requirements are. All right. Have a good day. Got 2 pictures here from our Feel Good photo gallery. Some of your classmates submitted these. They're cats and some rabbits. And also want to say that I've really been enjoying studying your national park assignments. That's been bringing me some good feelings as I look at all the amazing places in the world. And it reminds me that the world is an incredible, awesome place. And once we get through this current period of history, we'll be able to get back out in it. And there are amazing things yet to come. So, have a great day. And again, let me know if you need anything. And I'll talk to you later.